Hey there, everyone. So we're just going to continue with this whole completing the square. In particular, though, we're going to focus on a little bit more complex completing the squares. Now, before, we only did the problems where the leading term a was always a positive one. If it wasn't a one, we were able to, GCF it out until we had something like that. But now we're actually going to look at it, what happens when we have fractions involved. So we're able to do something like this. Now, if we have a quadratic equation that looks like this, here, when we try to solve it, we're not going to end up having a nice even thing that we can GCF. 2, 7, if I subtract the 2 over, I get -5. They're all prime numbers. There's nothing I can divide that they share. So I'm gonna have to do something a little bit different. Basically, in the beginning, when I get to step two, I do something a little bit different. But for the most part, it's the same thing. Again, though, it's a little bit more complex. So if you remember, step one is basically divide everything over to one side, so that we have it in standard form. Now, with step two, if you recall, that was when we ended up cleaning things up and moving terms over. Here, what we're going to do is we're going to actually divide everything by 2. So that is our next step. So again, we're going to end up with a leading term of 1, but now our middle and last terms are going to be fractions. Step 3 is the same thing where we take the constant term and we move it over to the right side. So since it's -5/2, we're going to add the 5/2 over. Step 4 is the same where we take half of the b term and square it and then add it to both sides. So here, 7/2, if you half it again, that that denominator gets multiplied by 2, so it becomes 7/4. And then we're going to square it and again add it to both sides. With step 5, what we're going to do is take the left hand side and write it as a binomial like this that's being squared. So x plus 7/4, all that's going to be squared. And the right hand side, we're actually just going to combine those two terms. So 5/2 and 49/16. That's what happens when we square top and bottom. Now remember, when you add fractions, you kind of have to get the same base. You can't just add them straight up. You'd have to make sure that the denominator equals 16. You could also plug in your calculator, and if you have a graphing calculator, you should have it set where you can actually set it to fraction mode. And then step 6 is where we kind of do the rest of the math. So you do square root of both sides, plus or minus. Here you do the square root of 89 over 16. 16 is a perfect square, so we can rewrite this as the square root of 89 divided by 4. So the 4 is no longer in the radical. Only the 89 is in the radical. So then when we solve for x, we end up getting -7 over 4 plus or not minus radical 8/9 over 4. All right? And that's pretty much it. So like I said, everything about completing the square is the same. It's just that now we're going to have slightly messier numbers at the end. All right, so here's the first question. Pause the video, work itself. I'll go over in a second. All right, so here they want to know which number he ends up adding. So what we want to do is start going through the process of completing the square. So step one, we're going to move the -7x. We're going to add it to the other side. Now there's no other term with an x, so it's just going to be x squared plus 7x minus 11 equals 0. We'll move the second step, we'll move the 11 over to here. X squared plus 7x equals 11. Then we're going to take half of the b term, which would make it 7 over 2, and we're going to square it and add it to both sides. So 7 over 2 squared. So right there I can stop. This is the term I'm looking for. 7 squared over 2 squared. 7 squared is 49. 2 squared is 4. So my answer is C. All right, here's the next set. Pause the video, work itself, and we'll go over in a second. All right, so what we're going to end up doing is same thing we did before. We're going to add these terms to the other side. So add the a, add the 1. We get negative 2a squared plus a plus 1 equals 0. Because this is an leading 1, divide all the terms by negative 2. And then you end up getting a squared minus 1/2 of a minus 1/2 equals 0. Now it's important that you wait until you have the 0 on the right hand before you divide. Now over here, I'm going to add 1/2 to both sides, or to the other side, I should say. And you end up with a squared minus 1/2 of a equals 1/2. Then we take that middle term, 1/2, and half it. That becomes 1/4. We're going to square it and add it to both sides. Like that. Then what I'm going to do is I'm going to factor this. Now I have to be careful. This middle term is negative while this term is positive. So this is going to be a minus 1/4. If both terms are, both b and c are positive, then this would be positive. But if one of them is negative, in particular that middle one, then it also has to be negative. And then on the right hand side, I'm going to have 1/2 plus 1 over 16. I'm going to have to end up cleaning this up a bit. So 1/2, I can actually rewrite that as 8 over 16 and add it to 1 over 16, which gives me 9 over 16. And then from here, I'm going to do what I normally do. I'm going to square root both sides. And then what I'm going to end up having is a minus 1 over 4 equals the square root of 9 is 3, and the square root of 16 is 4. So I'm going to have 3 over 4, plus or minus. From here, I can add 1/4 to both sides. And I'm going to end up getting a equals 1 over 4 plus or minus 3 over 4. So my two options are I can add them. So 1/4 plus 3/4 will actually give me 4 over 4, which is 1. Or I can subtract them, 1/4 minus 3/4. If you plug that in your calculator, you'll end up getting negative 2/4 or negative 1/2. So you end up getting, as a solution set, negative 1/2 and 1. And again, you can plug these numbers in real quick and see if these are the answers you get. All right. Down here, we do the same thing. We're going to add the 2 over to the other side. Get 2x squared minus 6x plus 3 equals 0. Do the same thing where you divide it by whatever the number in front of the x squared is, and you end up getting x squared minus 3x plus 3/2. So this was very close to not having to do any crazy fractions. All right, subtract the 3/2 over. You end up with x squared minus 3x equals negative 3/2. Going to take half of that middle term, which is 3/2, square it, and add it to both sides. So now, when I factor the left-hand side, it's going to factor as 3. Once again, middle term is negative. So x minus 3/2 squared equals minus 3/2 plus 3 squared is 9
and 2 squared is 4. So I get minus 3 halves plus 9 over 4. Uh, I'm going to simplify this. So 3 halves, I can get it equal to, because I have to get these the same base if I want to add these fractions. So I have to multiply the top and bottom by 2, get negative 6 over 4 plus 9 over 4. When I simplify that, that will actually end up becoming 3 over 4. So you take the square root of both sides, and you end up with x minus 3 halves equals plus or minus uh, square root of 3. I know 4 is a perfect square, so I'm just going to take the square root of that and get 2. And I'm going to leave it out of the radical. From here, I can now add the 3 halves over to the other side. And my solution set will end up being 3 halves plus rad 3 over 2 and 3 halves minus rad 3 over 2. And that's pretty much it. Here's the next set. Pause the video, work itself, and we'll go over in a second. Now, as I said, you're going to need to be able to get these solution sets for all the different ways. If I don't specify the way, you can choose whichever method's better for you. Some people might find completing the square easier, some might find quadratic to be easier, but you can choose whichever one you want, but you should know how they all work. So for completing the square, I'm just going to take this, it's already in standard form, subtract the 9 over. Actually, before I do that, I want to divide all the terms by 4. So this becomes r squared minus 20 divided by 4 is 5r. And then this will end up being plus 9 over 4 equals 0. Now I'm going to move the 9/4 over. And you end up getting r squared minus 5r equals minus 9 over 4. Take half of the middle term, 5 halves, square it, and add it to both sides. Uh, when I factor this, it's just going to become r plus 5 halves squared. Uh, since this middle term's a negative, that actually tells me it's not going to be plus 5 halves, but I'll have to actually make this a negative 5 halves. Over here, this will end up being minus 9 over 4 plus 25 over 4. This time the bases are actually even, so when I do 25 minus 9, I will end up getting 16 over 4, which does actually simplify in a nice way. This is equal to 4. So take this, take the square root of both sides, and I'll end up getting r minus 5 halves equals 2. Plus or minus 2, sorry. So I'm going to add the 5 halves over. And my solutions will end up being 5 halves plus or minus. I'm going to rewrite this as a fraction, even though it's a whole number, as 4 divided by 2. That way it's going to make this next part a little bit easier. So I can add them together and get 9 over 2, or I can subtract it and get 1 over 2. So my solution set would be a 1 half and a 9 half. Now, if I use the quadratic formula, I would use this original equation. Remember, it's negative b plus or minus the square root of b squared minus 4a C all over 2a. Negative times a negative is a positive, so this is 20. Underneath the radical, when I plug all this stuff in, making sure to type it in the calculator exactly as you see it here, you get 256. And this will be divided by 8. Now, if you plug it into the calculator, 256 is a perfect square. This simplifies as 20 plus or minus 16 over 8. So my two solutions will be 20 plus 16, which when I do that is 36 divided by 8, and then 20 minus 16, which is 4 over 8. 36 divided by 8, if I clean that up, will end up being 9 halves. And this one, when I clean it up, will be 1 half. So I get the same numbers up there. Okay? That's pretty much it. There's really not much difference. Like I said, it's a little bit more practice using completing the square. So continue with the other questions. You're going to submit those in later. Don't forget to answer these exit questions. So pause the video and answer it real quick. All right. If you have any questions, please let me know. Contact me immediately. Good luck and have a great day.